Hey guys, good morning. My topic for today is somewhat of a pipe dream that I've been having for many, many years of my career. What if cardinality was free? Today is more of a walk through that dreamland of mine and maybe even a collaborative thought exercise on how can observability tools evolve and help SREs. A little bit about myself first. We Just give me one second. All right. So before I decided to literally ride into the sunset or sunrise, as my wife makes me call it, I used to be an observability tech lead at Netflix for about 7 years. A little backstory before I joined Netflix. I used to be one of those people who got a lot of joy from building uh, apps and services that actually impact revenue of the company. So, for example, I used to be an engineer at, or like the second employee at this algorithmic trading company, where the only use of Grafana was to watch dollars on a Grafana dashboard. After that, I joined real-time bidding, where we were bidding for ads and millions of RPS and trying to figure out how much money are we actually making for our customers. And then, this gentleman called Roy Rappaport, which some of you here might know, my boss at Netflix, who convinced me to join, told me that, hey, you should come work for Netflix, and your customers are actually engineers. And I just couldn't fathom that idea. That just made no sense. I'm like, why would I do the boring? And he answered it in one sentence, and which is because your customer is you. And that's when I realized that I actually love troubleshooting. And what I enjoy even more is learning from the troubleshooting journeys of others. And how does that actually impact my work? That's where I derive a lot of joy. A couple of disclaimers about my talk. I sincerely believe that pictures, especially moving ones, speak louder than words, which means that as you see me fidgeting through some of the videos that I would like to show you, please excuse the inconvenience. Also, I'm going to be giving a lot of examples, but they are not real ones. They are toy or demo use cases that are inspired from a Netflix-like streaming service. All right, so cardinality. Very quick primer on cardinality. Cardinality is the number of distinct values that are associated with a tag on a metric. So let's take an example of the staple CPU metric from a Kubernetes environment. So let's say if you have something like container CPU usage with dimensions like cluster, host, pod, and container, and if each one of these dimensions had, let's say, up to 10 values, then in the worst case scenario, you could have up to 10,000 time series coming from a single metric. And we all know how many system metrics there are from the Kubernetes environment. What makes matters worse is custom or business metrics that actually give you visibility on how your business is doing, bring in even more cardinality. So here's an example. If you take the signups metric and imagine that it has dimensions like the country or the state or the device type, the app that we are getting a sign up from, and the version of that app, the total number of distinct time series can go up to 3 million. And so now the problem really comes down to if observability vendors out there start charging by either the number of time series that you're ingesting or the number of data points or samples per second, now it creates this world of misaligned incentives, as I call it. A 30,000 feet view of sort of three personas, if you like engineering leader, developer, and SRE, and what are the observability domains that they care about. If you're an engineering leader, you care about business observability. You care about your KPIs. You care about metrics that actually govern or can actually demonstrate the impact on your business from an ongoing incident. If you're a developer, you clearly care about your application. You care about maybe even the infrastructure that that application runs on. If you're an SRE, you care about all of those three. But cost is something that engineering leaders care about the most. However, developers and SREs may care about it because as and when costs rise, they need to do something about this problem. But the leaders are the ones who are going to those weekly or monthly cost review meetings and figuring out, like, wait a minute, my team actually needs to do something about this. And so the result is something like this. The leader comes in with a, hey, we need to reduce these costs. The engineers are happy to oblige. And the short end of the stick is what SREs get, especially during an incident. But again, if cardinality was free, how would this world evolve? And this is really what this talk is all about. What are some tools or what are some user experiences that we can imagine if this tool didn't really charge us for cardinality? And which means that this leader doesn't care about reducing costs, or they still do, but the impact of that reduction doesn't come to, hey, chop this metric or chop these dimensions off. And so here's scenario one. Customer service at this streaming service that hereby shall not be named just reported, well, the Crown that was just released on our app this week stopped playing. The leader comes in and says, no, that's a problem. This is a super anticipated title. Press is giving us some attention now. This is bad. Let's fix it. The SREs go, well, movie ID is a tag that I would need, you would think, to debug this specific problem, but it's really missing. And the engineer comes in, well, I dropped it because, hey, leader, you asked me to drop costs, and peace out. And that's when, by the way, excuse my use of Boss Baby. My kids love it, and I love it too. And the leaders are like, wait a minute, it is true. I did cause this particular behavior, but now we are in a real pickle. But imagine if while that SRE or that engineer starts troubleshooting, imagine once they go into their tool, if all of the metrics that are their favorite metrics that tell them about the health of playback, if there was that natural assumption that if I see a metric called movie play starts or movie play errors, these metrics will have all the attributes that I need to debug any problem that is being shown in this specific metric. Today, we are missing that basic guarantee that those dimensions will even exist. But if they did, we could treat each one of these metrics as if they were relational database tables. It's almost like if error rates was a relational table, and if, let's say, something that errors can come from is license validations, you could now write maybe even SQL queries that join between these two tables on movie ID. What could this look like? So give me a second. So here we are basically playing, and a lot of credit here goes to my co-founder, Kunal, who's in the back, who helped put all of these ideas in a prototype that we can actually show you to inspire this conversation further. But we selected the movie play errors metric. We did a group by movie ID. And now, once we identified the movie ID that corresponds to the one having the problem, I can basically just click on that line and ask for a join with whatever other metrics that exist in the system that have that exact same movie ID. And this is that guarantee, the kind of guarantee that you have, like, I know these 5 relational tables exist, and these 5 tables are supposed to have this dimension. Why can't I get a better join? Why can't I just make that so much easier? Going to a more relatable example from the system domain. In this case, now we are going to go look for a system metric, something like container memory usage. And what I'm trying to do is do a group by. And as that comes through, now when I locate a pod that might be an outlier, I want to see what else is going on with that pod. Now, a little fun fact about dimensions as fundamental as pod name, there are a lot of vendors out there that will actually say pod name is regarded as high cardinality. I will not name those vendors, but you will be able to, unless you actually flip a flag called enable high cardinality, you wouldn't even see pod name on the other side. And that completely precludes experiences like this one. Fun scenario. So now we are seeing a error rate spike. This is a general spike in error rates. Something is wrong. It's 3:30 a.m. User calls start pouring in. Hey, movies are not playing. The SRE gets paged. The context is simply plays are failing, cryptic error code. And then this is somewhat of the timeline that you can expect, and I'm assuming you are familiar with. The first question is, well, for once in my life, can it be something less cryptic that I start my journey with? The second one is, I know what my popular dashboards are. These are the things that I would typically go to. Let me fire them up and start looking for anything abnormal at all. Everything mostly looks normal, except maybe this one metric that says something called errors in its name seems to have a bump. Let's start digging further. And that's when the slicing and dicing begins. The problem here is that if this metric has a lot of different dimensions, the problem could be coming from any combination of these tags and any combination of the values of those tags. And so a lot of this is now basically fighting the query builder and going at it and spamming it, where the only thing that might be working in your favor is effectively the tribal knowledge of it's typically if you group by these dimensions and if you look for these specific values, that's where the spike can be explained from. And that tribal knowledge is typically in the heads of the most senior SREs at the organization. And what could this look like if this was easier? I go looking for the errors metric. I find that there is a region of the chart which is actually spiky. I go in and I highlight that region. And now the tool, which can assume that all of these dimensions actually exist in their full fidelity and glory, uses common machine learning techniques like maybe principal component analysis and figures out the cohort where that spike might be coming from. The cohort in this case is identified by the reason, which is CDN offline, and the states. Now, someone who had no tribal knowledge about this metric or what it does might actually be able to start reasoning about, wait a minute, I know what CDN offline means, and I can read those state codes, and I can actually read that pie chart on the right-hand side, which will soon show up. Oh, wait a minute. We also could do the metric joins that I was showing on my earlier slide. And now, instead of manually trying to find what else, you could find the starts metric, if I may rewind, was also hosed in those three states during that same exact time frame. And more importantly, this is where you can have reliable AI, because now what the tool found through basic statistical techniques can be explained much better by AI to someone who had no understanding or prior tribal knowledge about these metric or metrics. And so what else can cardinality do for you? And this is more of by the way, this is, I think, my second last or my last slide. And the reason for having a short talk is, like I said earlier, I would love for this forum to be a conversation where we actually start talking about what ideas, how can tools and how can gestures emerge in these tools, and what would those gestures look like that would actually make us much more productive at troubleshooting. And so, for example, some other ideas that we have are alert notifications can now come in with context attached. When an alert fires, you might have a alert on an aggregate level metric, but when it actually comes to you, that notification has the context broken down because the tool figured out that these cohorts are actually responsible for this spike. We could reduce handoffs. Handoffs are the number one problem, at least in my opinion, when it comes to troubleshooting. I'm looking at this specific metric. This metric has a problem, except this metric is coming in from a service that I don't own. Who owns this? Hey, this thing is showing a spike. Why don't you take a look? If you just had an ability to actually highlight that bump and figure out what might be going on there and get a non-cryptic description of what might be going on, now you're off to the races. You can actually go hit that other person with more context and actually annoy them less. And obviously, the very self-explanatory mean time to resolve and mean time to understand. I think a lot of emphasis needs to be put on mean time to understand. It's sort of the metric that we don't measure, also because it's not easy to measure objectively. But one way that I have found is what is the speed or the velocity at which a junior engineer, and when I say junior, not by tenure, but a junior engineer on the team, in terms of their experience on the team, comes in and starts becoming a productive member of a troubleshooting activity for an incident. If they are coming in and they're mostly soaking all of this knowledge in and then going like, wait a minute, oh boy, these people have a lot of tribal knowledge. I hope there's a run book for this. If not, my first contribution is going to be writing one of those. And wait a minute, those are run books that I wrote and I'll be the biggest advocate for it, but they would probably not get utilized, or that tribal knowledge won't propagate at the rate at which it should. And so long story short, the mean time to understand can be measured as what are the number of months an engineer who's new on the team takes to actually start proactively leading a troubleshooting journey or an incident for that matter. And for that, they shouldn't be on their own. I think if tools had unlimited cardinality, they could do this for that engineer and meet them halfway. That's all I had to say. Thank you.
Thank you, Ruchir. Do you have any questions for Ruchir? Incoming from behind.
What invention is needed to have a storage system that can do this kind of high cardinality storage like cost effectively?
I would say the first thing that is needed is to go back in our own brains and ask the question, what other domain do you naturally find very high cardinality? And one domain is data warehousing. You don't think about adding a dimension like customer ID or movie ID or any one of these IDs to that data set, but you have to think before you add it to your observability data set. So if observability data sets could actually be traversed through more of that data warehousing lens, now it will become easier. And for that to happen, the first thing that needs to happen is liberating that data from the observability vendor. You need to be able to use innovations like OpenTelemetry so that you can divert that data to, if you want, a data warehouse. And now, even if it is not something, I would love for the vendors out there to start thinking about what gestures would make that UX easier. But even if before that UX arrives, just going into that SQL editor and firing up that query would be a significantly better experience than having to wonder which cohorts are responsible for this pipe.
Yeah, fantastic talk. I have a question around how you see this relating to wide events and tracing data that is typically higher in cardinality to start with. Yeah, just kind of a general question.
No, I think tracing data is awesome. I love tracing. I believe this is still the case, but even at Netflix, we used to take less than 0.5% in terms of the actual amount of traces that we would ingest into the system. And that was mid-8 numbers, in millions of RPS of spans. The problem is sampling. And what that really creates is broken traces. If you are not looking at the complete picture of the world, you're actually looking at a lie. And so I love it. I see the big value that tracing offers, and I would love to do a lot more with tracing. But what I would like to do more is sort of figure out how do we get all of that data in, and how do we summarize and aggregate it so that it becomes easier to wrangle. I'm sorry if I didn't answer your question, but
that was good. Thank you.
Day zero concerns. Yeah.